Hi everyone, this is Nick. Welcome to Duality Repair and welcome to Chapter 2 of this Pioneer SX 1980 series. If you haven't seen Chapter 1, the first video, you're going to want to go back and take a look at that. You missed quite a bit of work that I did to both amplifier channels. In this video, I hope to tackle the entire power supply section. So I'll replace all 4 bulk electrolytic capacitors. We'll take a look at these 2 rectifier boards. We'll deal with the power supply board itself, and I hope to also do an initial power-up test. So let's get started. Let's start with the bulk electrolytic caps. These are the original from Nippon Chemicon, 22,000 microfarad rated at 100 volts and 85 degrees C. These are absolutely massive, definitely the largest electrolytics I've had to deal with so far. The replacement I have is also from Nippon Chemicon. These are also 22,000 microfarad, but a higher voltage rating at 160 volts and a higher temperature rating at 105 degrees C. So these are a definite upgrade compared to the original. They compare in size almost identically in height, and they are identical in diameter at 3 inches. So these are going to work really well. Before installing the new bulk caps, there's just a few things I want to consider. First, the original caps were labeled from the negative terminal, and this is important because I'm using this label as a reference. I took images of all 4 caps before removing them from the unit so that I ensure that I install the new caps with the correct polarity. And of course, the new ones are labeled from the positive terminal. So obviously you could have a really bad day if you install those incorrectly, so I'll probably double and triple check the installation of these to make sure that the polarity is correct before I call them good, and probably double and triple check again before I decide to power it on. And second, although the caps are pretty much identical in size, you can see the terminals on the new caps are just a little bit longer. They stick out about 3 or 4 millimeters more than the terminals on the original capacitor did. And the concern there is you can see where the capacitors are mounted here and here. Behind here is the rectifier board. So you can see this side, there's really no concern. There's nothing on the board. But on this side, you have 4 terminals. And so if those terminals of the capacitor stick out a little too long, and if this terminal here comes into contact with any of those, obviously that could be a really bad day as well. And so to resolve that issue, I'm just going to back this board out a little bit relative to the unit. So you can see where they're mounted here and here, and I'm just going to put 3 or 4 washers in between the board and these little mounting brackets here that should back the board off enough to ensure that the terminals are nowhere near that rectifier board. Well, here's an annoying little oversight on my part. The new caps require a bolt of a slightly larger diameter. You can see the new ones on the right there. And so not only am I going to have to find a larger style ring connector, but I'm also going to have to drill out larger holes in this ground plate here. I have some larger ring terminals mounted to each rail now and mounted to the capacitors. I drilled out larger holes on either side of that ground plate. So all I need to do is reconnect the rectifier board, and this side is done. All 4 bulk caps have been replaced, and I think they look really nice. So I'm ready to move on to the power supply board. I've done some research on the 1980, and it seems like the power supply board is the Achilles heel of this unit. Apparently it wasn't designed very well, it runs really hot, and so certain components are subject to early failure. And so I'm not surprised that 4 of the 6 regulator transistors have already been replaced. These 2 appear to be original. And so I could go through and completely rebuild this board. I'd replace all of the electrolytics, probably replace all 6 regulator transistors, inspect and replace as necessary all of the other components. These 2 relays are suspect. I could do all of that and it would probably work just fine, at least for a while, but because it's the original design, it's still going to be susceptible to those same failures. And so I'm going to go with this instead. This is a completely redesigned power supply board specifically for the 1980. It's done by an individual or group in Canada. And this design specifically eliminates the issues that were present on the original power supply. And so this is going to make the entire unit a lot more robust. I think it's going to add a lot of value. All done with that. These wire markers are absolutely essential in an application like this. All right, the power supply has been removed successfully, and let's take a look at it. Oh my gosh. Did I dodge a bullet or what? Look at this. What happened? This is absolutely atrocious. Let's get the new one in. Just about done wiring up the new power supply. The last thing to do is to get these two wires, 1 and 2, attached to this connector here. These go to the main power switch in the front. So they'll feed into this connector, which uses this type of pin. Unfortunately, in the kit I was sent, I only have 2 pins, so there's no room to make any mistakes. And I'm pretty sure with this style of pin, you need a very specific crimper to get it done properly. So I don't have that. I'm not going to order one just for this, so I'm going to do the best I can with just a standard pliers. I may need to add some solder as well, but we'll get it done. All right, and that's it. The new power supply is completely wired up. I think I'm at the point where I'm ready to double check everything that I've done up to this point and then try a power up test. All right, let's perform the initial power up test of this 1980. I know most people like to use a dim bulb tester in this situation. I'm going to try a different method. You see I have the unit hooked up to my variac, and I'm going to use this clamp meter to monitor the AC current. If there's a significant problem like a short, we're going to find out very, very quickly. A few things we want to watch for. Number 1, the current. If it rises too fast, I will shut the unit off immediately. Number 2, there are 4 LEDs on the power supply board, and we're looking for those to illuminate at a certain point. And then number 3, we should hear some relays engage at some point as well. So I have the switch on the front of the unit powered on. Let's turn on the variac. I'm at 0 volts. Let's crank it up to 25. So far, so good. We're only at about 60 milliamps. Not a problem. Let's go a little bit more. There's close to 50 volts AC. No action from the LEDs yet. I haven't heard any relays engage. Current is only about 115 milliamps. Still no problems. Let's go a little bit more. I heard some relays, and I see some LEDs illuminated. That's great news. We're at about 90 volts or so AC and 460 milliamps. So far, so good. Let's keep going. It's about 100 volts, and that's pretty close to 120 volts AC at the input. All 4 LEDs are illuminated. We heard the relays engage, and our current is between 650 and 700 milliamps. Not a problem at all. So I think so far so good. I'm very pleased. I think I'll let the receiver run like this for just a little bit longer. If it still looks good, I think it's time to measure some voltages. The receiver's been on for about 15 minutes now, and the current is holding pretty steady around 710, 720 milliamps. So let's test some of the lower voltages. Now there's no load on this circuit, and so I'm not expecting anything to be exact. We're just looking for ballpark numbers here. So we'll start at the top. This should be 8 volts. 5 volts. 13.5. 30. 35, excuse me. That's correct. Negative 35 and negative 30. Yeah, so this power supply is looking great. And that's to be expected. These pre-built power supplies are tested before they're shipped out. So really the only problem that can come up is if you wired incorrectly, which is of course always a possibility. I don't think that happened in this case, so it's looking great, feeling pretty good about it. Let's move on to the rail voltages. We'll start with the positive rail of the right amp. Right around 94 volts. Here's the negative rail. Good, right around negative 94 volts. Here's the positive rail of the left amp. Again, right around 94 volts. And here's the negative rail, right around negative 94 volts. So everything is checking out great so far. I think I want to do a preliminary check of each amp's bias and DC offset. I was wondering when we were going to see a problem. Things have been going much too smoothly up to this point. There are just far too many ways for things to go wrong. So you can see I'm hooked up to the right channel. I've rotated the potentiometer all the way to its counterclockwise and clockwise hard stops, and I get absolutely nothing for bias, idle current. So there's something wrong with the right amplifier. Let's switch gears to troubleshooting mode. I'm going to start by ruling out the idle current potentiometer itself. This is a 100 ohm potentiometer. Yeah, this looks just fine. When troubleshooting, I'm typically very specific about what components I want to look at, but in this case, I have so much work to do on this unit that I took a little bit more of a shotgun approach. And so you can see I removed the board from the unit again, and I thoroughly inspected every single resistor and diode on the board, and they're all measuring as they should be. So I have no concerns there. You can see I also removed all of the transistors. I measured all of those as well, and there actually is one that is showing an issue. That's this one here. And the peak meter is detecting it as a PNP digital transistor. Now the PNP is correct, but this is certainly not a digital transistor. It does give you the pinout, which is correct, but there's no other information. So there's definitely a problem with this. This is Q16, and this is actually the constant current source for the bias circuitry. So this is a very critical transistor, and it could certainly be part or all of our bias problem with this amplifier. Since all of the transistors are original and removed from the board, I'm just going to replace all of them, and then of course this failed one Q16 as well. I'm also going to replace the two potentiometers just to be safe, even though they're both measuring just fine. I've heard from many sources that they can be a source of concern down the road, so we might as well prevent that issue while we can. I also decided to replace this. This is the differential input pair in one package. It's two PNP transistors, and although the peak meter was able to detect both transistors, the delta in the beta, or the gain, between the two transistors is more than I'm comfortable with, about 20%. And so I made this custom differential input pair here. It's made with two KSA 992 transistors, TO92 style. And I checked the beta for each of these before and made sure that they were extremely close. Of course, I heat shrunk them together and put some thermal compound in between the two as well. And they are joined together in the center, which is the emitter, just like the original package. And before I installed this, after everything cooled down, I checked the beta for both of these transistors, and they are reading within 1%. So I'm much more comfortable with that. They're very close to the original gain, I'd say the average gain of these two, but the delta between the two is extremely small. So I think this is going to work well. All right, the right amplifier board has received all new transistors and two new adjustment potentiometers. I think it looks really nice. I was able to dial in both the idle current and DC offset to spec, and I got a little bit risky, decided to hook up a signal, but take a look at this. We have a beautiful looking signal from the right amplifier board. Now this is only 2 volts peak to peak. I'm a little bit hesitant to crank it up any further at this time, but I'm really excited we actually have an output from this right amplifier. This is working. So I'm going to move on to the left channel. I finished rebuilding the left amplifier board, and I was able to adjust the idle current and DC offset to spec. If anyone tries to tell you that the original transistors of the Pioneer SX 1980 cannot be replaced with modern ones, you can tell them to think again. Both channels have been running at about 50 watts for 20 minutes with absolutely no problems. Both heat sinks are practically cool to the touch. So I would say the power supply is working well, the new bulk caps are working well, both amplifier modules are working well. We haven't talked about them at all, but both rectifier boards are working well. So I'm going to call it for this chapter, Chapter 2 of the Pioneer SX 1980 series. Join me on the next video when we're going to tear apart the front end and take a look at all of those boards. Thanks for watching.